community, and welcome back to another official Unity live stream here on both twitch.tv/Unity as well as on the official Unity YouTube page. My name is Jackson. I am one of your community managers, and it is my job to bring you the latest and greatest in Unity live stream content. Thank you so very much for being here. Whether you're tuning in on YouTube or on Twitch, thank you for hanging out with us. And again, as always, please be aware that this is a conversation. We want you all to be here, to hang out, to feel engaged, to ask questions, to be curious, and to learn something. It is our hope with every single stream that you learn something, you feel inspired by something, you connect with the fellow Unity community, and maybe that you have a little bit of fun. Thank you so much for hanging out. If you were watching this video after the fact as a VOD on YouTube, feel free to take a look down at that navigation bar and skip ahead to the chapters that most appeal to you, because we have a fantastic stream planned for you. We are bringing back beloved guest. Absolutely crushed it in his last stream that he joined us for. We got Ben Cloward coming in to hang out to show us a little bit more about Shader Graph with a sample 3-pack, basically. Now, whether or not we bring Ben back every month or what this looks like is yet to be decided, but we know that we had such a good time with Ben last time, and it seems like everyone was so curious about Shader Graph, and there was so much more to learn that maybe we continue a series of how-to Shader Graph, regardless of what the future looks like. We've got today's stream, and I'm looking forward to it. Again, looking to you all in the chat. Great to see some familiar faces, some returning names over on the Twitch side. We got Bigardi Tech, Bigardi Tech. I think that's right. And Andrew the Day. Great to see you over on YouTube. Familiar faces, of course, Mr. Awesome, the Bull Divina. We got PZ game developer Nam Tran. Everybody, regardless of where you are tuning in from, thank you so very much for hanging out with us today. Housekeeping is short. Of course, we are looking to stream about 2 times a week for the next couple of months to bring you more and more content in hopes that you find something that you connect with, something to learn, something to be excited about. So, of course, this week we have today's stream. Thank you for being here. Tomorrow, we've got our next edition of Versus Mode, which, of course, is our game show where we pit a Unity representative against a community, a game dev representative. And we've got our 3rd episode tomorrow. Team community is up 2-0 on the lifetime scoreboard, so it's looking a little bit rough on our side. We'll see if we can reclaim some of our former glory, but that's exciting for tomorrow. Today, like I said, we are diving into a 3-pack of samples in Shader Graph, and I can't do it alone, so I think it's about time we bring back the man, the myth, the legend. Everybody in the Unity community, please say hello to Ben Cloward. Ben, welcome back. How you doing today?
Hey, Jackson. Thanks a lot for having me on the show again.
Of course, of course. I mean, always a pleasure. And we were talking about this, but I'm going to let everybody in the Unity community in on this as well, that working with Ben is a dream. It's like, it's so smooth. It's smooth as butter because Ben works on these tools, creates these pieces, and for him to come in and know exactly what he wants to show everybody and get everybody excited for is so natural. Ben, if anyone missed the last one and wasn't here, unlike Andrew the Day, who in the Twitch chat says, after the last stream, I discovered Ben's YouTube channel and his procedural shapes tutorial was really helpful. In helping me optimize some of my shaders. So thank you. So Ben, if anyone wasn't here, like Andrew was, tell everybody a little bit about yourself.
Sure. So I'm Ben Cloward, and I have a YouTube channel, if you're interested in that, where I post just about every week a new tutorial video for how to create shaders. That's my passion. I joined Unity about 4 years ago as a technical artist. I work on the Shader Graph team, so I help to develop the tool that we're going to be looking at today. Before joining Unity, I worked at BioWare for about 14 years, also as a tech artist. Shaders and optimization are my passion, and I love helping people learn how to use this tool that we're going to be taking a look at today.
Yeah, absolutely. So I feel like We were talking a little bit about it, but do you want to name drop some of the projects that you've worked on? Because I think, Ben, it's an impressive list.
Sure. Yeah. Before coming to Unity at BioWare, I worked on the Anthem looter shooter game. And then before that, I also worked on Star Wars The Old Republic for about 8 years. And I started in the industry in 1999. And fun fact, the characters that I was making for the PlayStation 1 back in those days had fewer polygons for the whole character than some of the characters in Anthem had for their eyelashes.
Whoa!
So that kind of gives you an idea of the spread of my career spanning 20, 25-ish years.
Dang, that's very impressive. I like that a lot. Thank you. I mean, listen, I love like a metaphor and just something about that puts like a really beautiful button on it. Like we really understand the career trajectory in there. Again, thank you to everybody in the Unity community for being here. Please let us know where in the world you are tuning in from and whether or not you have any experience in shader graph. We have put Ben's YouTube channel in the chat in both the Twitch and YouTube side. Please go and check out Ben's channel. It has all of the very short form, very straight to the point, very direct tutorial style content. You will learn a lot there. Ben's channel is exceptionally catered towards helping you all grow and learn, which is great. However, the way that we will approach things today is going to be a little bit less. This is a very social environment. This is a very conversational environment. You in the Unity community, feel free to ask questions. We'll try and get them in front of Ben wherever we're able to. And we're just going to hang out and chat as Ben kind of showcases some of these things. But again, if you want the super direct how-to overview tutorial type content, go check out Ben Cloward on YouTube, youtube.com/Ben Cloward. Ben, I'm really excited. Do we want to talk about today's plan?
Yeah. I do want to give a quick recap just to help people realize like what we talked about last time. So I talked briefly about what shader graph is, and then we spent most of our previous stream looking at the sample content that's available for shader graph. If you could share my screen really quickly, I want to show this just as a refresher. If we come here under the Windows menu and open up Package Manager, and last time, I don't know if you remember, Jackson, but I was joking with you, like if you want to make sure that nobody ever finds something in Unity, put it in the Package Manager. So here's the Package Manager window. If you come down to the shader graph package and then switch over to the Samples tab, most of the time that we spent on last stream was going over the node reference sample, the feature example sample, and the production ready shaders sample. And I want to put in another plug for that because it is some fantastic content. Today, we're going to get a little more hands-on, and I'd like to walk you through, just like Jackson said, 3 examples of shaders and show you step-by-step how to make them. So you're welcome to open your editor and follow along. We're going to be doing this node by node. And at each step, I'll explain the nodes we're using and what's happening to make these shaders work.
Awesome. So we've got 3 that we're planning today. What are the 3 individual ones? How would we have people approach situationally? Where might people want to utilize these shaders?
Yeah, so we're going to start out by looking at a Flipbook effect. And this is, I'll get into the details in just a second.
Sure.
After the Flipbook, I'm going to show you how to add an environment material like moss, sand, or snow to the tops of objects like rocks. And then finally, I'm going to show some simple cloth shading. And I'll explain more about each of these as we go along. But what I'm doing today is not really specifically focused on these effects, but the idea is I'm trying to use these as exercises to help us all learn some of the basic principles of shader creation. So even if you're not that interested in these specific effects, there will be principles that we go over along the way that you'll be able to use for lots of other things.
Yeah. What I loved about kind of getting ready for this stream is, Ben, you came to me and said that regardless of what we talk about, we want to kind of discuss the end goal and have applicable tips and concepts that people can walk away with. So no matter what, if you don't need to replicate this exact example, you're still going to learn things along the way that you will be able to apply in other ways throughout your journey. So I'm really
Yeah.
excited for that.
All right, I guess I'll just jump into it. Are you ready?
I'm ready. And I want everyone to buckle up because we've already seen some people that are like, oh, I wasn't here last time. We have Caleb Pye on the YouTube side says, started learning shader graph last week and then came across this stream advertised yesterday. So I'm excited. I want you to be aware that myself is not a designer or developer. As a purely community manager, the last time we had Ben on stream, the way that Ben presents this information, I was like, I'm ready to go. I think I'm changing career paths. So like, there's just something very, very engaging about the way that we do all of this. Ben, the way that you bring in and set up and engage with everyone, I'm excited, genuinely. So let's get into it. We're starting with Flipbook, correct?
That's right.
Let's
All
dive
right,
in.
so this first example, what we're trying to do is to create an animation that would otherwise be very expensive to do if you were rendering it offline. So for example, let me just pull up Photoshop here. I have an image here. This is the image that we're going to be using in our tutorial. What I've got here is an image that was either created as a practical effect, like somebody got a camera and a black screen behind it and actually filmed an explosion happening, or they did a fluid simulation in software like Houdini, for example, and it may have taken an hour per frame to render this.
Right.
But the idea here is that we want to create this animation and we want it to be able to play back in real time. And so we have these individual frames that have been rendered and then arranged as a texture map in rows. And what we need to do is make a shader that will show the frames one at a time. So we're able to play back these frames that we've pre-rendered instead of paying the enormous cost of doing this simulation in real time, which wouldn't even really be possible for your graphics card to do.
Mm-hmm.
If you're curious and you wonder where can I get a hold of a texture like this, let me just pull up a web browser here really quickly.
Because I was curious. I was going to
Yeah,
ask. Like that organized in that way is very, it's not something I see often. So is it easy for people to find these types of things?
right. So if you have the technical skill, you can use software like Houdini to render these out. You can arrange them in Photoshop, or you could probably do that in Houdini as well. But if you just want to try this, you can go to this blog post that Unity provided back in 2016. And I don't know if you can give them that link, Jackson.
I will find it. Yeah.
Okay, fantastic. So while he's doing that, I'm just going to scroll down here. And what this is it's a repository of just a whole bunch of these animations. I'm just going to kind of scroll down here slowly so that you can see.
Oh, cool.
All of these are done using this technique. So there's just a whole bunch of frames rendered out, and then they play them back with the shader that I'm about to show you how to create.
So this is cool. So what they would be able to download from this resource, which I have found the link and put in the chat, is the images in that kind of grid.
Yes.
And what we're going through today is taking those and utilizing them to create these things as the end product, correct?
Yeah, that's exactly right. So
Awesome.
they're going to grab the image grid here, and then I'm going to show you how to create the shader that will play these back. But I just want to kind of give you the idea that there are a lot of these. And if none of these are what you're looking for, I also went to the Unity Asset Store here, and I did a search for Flipbook texture, and there's just like hundreds of results of these. These are very popular to do for like visual effects, like explosions and that sort of thing. So just kind of scrolling through here, there's like tons of this available. Some of them for free, some of them for not too expensive, but there's a lot of these kinds of things available. All right, well, let's just jump in and start creating this shader. I have a scene set up, or I have a shader set up already with a couple of assets in it. But let me just show you really quickly how to do this if you haven't done that yet. So you can just come into your project, right click anywhere in your assets folder and just pick create shader graph. I have URP installed, but it works in HDRP just the same. And then we're going to pick unlit shader graph. So there's no lighting in this particular example. You could do it lit if you wanted to, but I'm going to do an unlit one today. All right, so this node here is sample texture 2D, and this is the one that is sampling our texture. So you can see the preview down here shows all of the different images lined up, and we can see those frames. And if I open up my little preview window here, right now nothing is plugged into our master stack, and so the preview is blank. But I'm just going to go ahead and plug my color into the base color input and my alpha channel into the alpha. That is the opacity. And now you can see my output is this grid. Now our goal here is to play these frames back one at a time. So right now we're just showing the whole grid. And so we need to use this node that comes with shader graph called Flipbook that's going to allow us to play these frames back. And the first thing, I'm just going to take the Flipbook node and plug it in, and you're going to see that nothing changed. And that's just because I don't have the Flipbook node set up correctly yet. So if we look at the width and the height inputs here, that represents how many rows and columns our image is divided into.
Okay.
So here I can see I've got 5 across and 5 down. So I need to give it a width of 5 and a height of 5.
Oh, interesting. So you're informing the Flipbook, giving it the information about the image itself.
Yeah, that's exactly right. So right now it's scaled our UV coordinates. So instead of showing the whole thing, I'm just showing the first frame. And now I've got this tile input here, and the tile input determines which frame I want to show. So I can type 1, I can type 2, 3, 4. So you can see as I increase this tile number, it's switching from one frame to the next. Okay, so if I want to animate these, I can bring in a node called time. And the time node just gives me a value that is like incrementing forever. Like as long as the Unity editor is open, the value of time is just going up and up and up. And so all I have to do is take time and plug it into the tile input. And now my tiles are advancing one after the other without me doing anything. Now, obviously this is going kind of slow. So we need to fix that. Just to help us out a little bit, I'm going to add a float node out here, and I'm going to set this to 5. I'm doing this because I want these values to be external from the node itself. I've got my number of rows and columns over here, but I want to isolate these out here so that I can do something else with them that we're about to do. So I'm just going to grab, so here's my number of rows and my number of columns, and I've plugged those in. Cool. So instead of using those default values on the Flipbook node, now I've separated them so they're their own nodes. So I want to control the speed. And so what I'm going to do, first thing that I want to do is figure out how many frames there are. And I can do that really easily just by multiplying the number of rows and columns together. So now the result of this multiply gives me the total number of frames, right? You just multiply the rows and the columns. And then the next thing that I need to do is multiply time by a speed value. So I'm gonna.
We're going a little slow. That's what we're aiming to solve for?
Yes, exactly.
Okay.
All right. So here I've got time, and then I can add another float node here. And this value that I multiply time by can control the speed. Okay. So let's just ignore what we did here, and I'm just going to plug this directly in here. And you can see right now I've multiplied time by 0. And so my movement is stopped, right? But I could multiply time by like 5. Now we're going a little bit faster. I can multiply it by 20. And now we're going kind of a more natural speed. All right, well, let's set time to something super slow for now. And I'll show you why in just a second. So I'm just going to kind of clean things up just a little bit. The next node that I'm going to add here is called the fraction node. And what this node does is it takes whatever number is coming out of here, so time multiplied by my speed value, and it gets rid of everything on the left side of the decimal and just gives me what's on the right side. So like I said before, time is a value that just keeps going up and up and up, and it's getting higher and higher and higher. But I want time to loop between 0 and 1. And so this fraction node is going to throw away the integer portion of the number and just give me the decimal portion of the number. Does that make sense? And so what I'm getting now is a value. Actually, let me speed up time here. So if we look at this preview, it goes from 0 to 1 and then jumps back to 0 and just keeps cycling like that.
Okay.
So if I take the result of that and multiply it by the number of frames, now I've got a value that goes from 0 up to the number of frames and then starts over again. So I can plug that into my tile value, and now I've got a cool looking explosion.
Dang. That's a grand reveal. That feels like a good, I mean, listen, Ben, you've got a sense of showmanship. It's a sneaky one, but it's like, okay, we're going to do all these things. And then the final thing is boom, climax, grand reveal. I loved it.
Yeah. All right. So we could stop here, but we can also do something else that's cool. What I'm going to do, just to show you, there is a little bit of a weakness in this. So I've only got 25 frames, right? And if I want to play, like let's say I want to do this explosion in slow motion. So we'll set the speed to like 0.2. And as we were seeing before, when it's slow, our movement is now really choppy. And so what I want to show next is a way that we can make this movement a little bit more smooth, even though our frame rate is low. So what I'm going to do is I'm going to take our texture sample and our Flipbook node and copy and paste them. So now we have 2 of them. And so we're actually calculating our Flipbook coordinates twice and then sampling our texture twice as well. And what we're going to do with this second copy is I'm going to make this version 1 frame ahead of the other version. So I'm just going to take the frame that we're on here, this multiply passed into tile. That's the current frame that we're on. And I'm going to add 1. So this version down here is going to be 1 frame ahead of the one that's on the top. And if we look at our preview here, I don't know if you'll be able to tell, but we can compare these two. You can see that this one is going along, but this one is like doing it 1 frame forward in time from the other one.
Mm-hmm.
And then we can blend between these two. So I'm going to take this frame that we're on here, and we're going to add another fraction node. And you can see that this one is just a mask that's blinking really quickly.
Strobing.
So we're going to use it to blend back and forth between our sample and whatever is the next frame. And so instead of jumping from frame to frame, now we're going to blend from frame to frame.
Awesome.
So I'm just going to add a lerp linear interpolate node, and this one is going to blend between 2 things based on a value that we give it. So I'm going to plug our first map into the A port here, and our second Flipbook sample into the B port. Then we're going to use this fraction node down here to blend between the 2 of them. So now instead of flipping, we are blending. All right, and I'm gonna.
That is so cool to see.
I'm gonna. Thanks, glad you like it. So I'm gonna.
I do.
I'm gonna plug this in here. We'll split out the alpha channel, and now in our preview, you can see that we have a smooth playback because instead of jumping from frame to frame, it's actually blending from 1 frame to the next. Now, doing it this way is a little bit more expensive because we're obviously calculating our Flipbook coordinates twice, and we're sampling our Flipbook texture twice instead of once. So if you want this to be as cheap as possible, just do it this way with a single one. But if you want it to be smoother, you can do this double method and blend. And the really nice thing about this is these Flipbook textures, I was showing you this in Photoshop a minute ago, because I have all of these frames in the image, I have to make a fairly large image in order to fit all the frames. And the more frames I have, either I have to have a bigger texture, which is using more memory, or each individual frame is low resolution. And the nice thing about this smoothing method that I've done here is it allows me to use fewer frames in my effect, but still make it smooth. And so that means I'm using a smaller texture, using less memory. I am trading that for a little bit more shader cost, but I am able to get an effect that still looks good, even though the frame rate is low.
This is, again, so cool. And I realize, not necessarily when I watch back video, but sometimes I just hear myself, I'm going to say this is cool like 700 times because I'm just genuinely excited about it. But I need to work on adjectives. I'll get to that. But I do want to bring in a couple of comments and questions from the chat here. Because again, if you're watching live, we are paying attention. This is a conversation. If you have questions, feel free to ask. If you have wonderful comments, please let us know. Franklin Weeks on the YouTube side says, I have only been working with Shader Graph for a few weeks, but have fallen in love with it. Ben, you are a tremendous teacher, and I feel your passion for Shader Graph really shows through. So I think that kind of alludes to something I was talking about earlier, where the last one of these that we did, Ben, I was like, I'm motivated. Like, I think just the level of passion and creativity that you carry is exceptional. Direct on the YouTube side says, what if you didn't want the black smoke in the last few frames? Would that be as easy as going into Photoshop, chopping off some of those frames, and then re-informing the node about your X and Y axis?
Yeah, you could do it that way. You could also probably rejigger the shader here in the graph to limit it so that it didn't display all of them. But if I were doing it, it's kind of a waste of texture memory to have frames in there that you're not using, and so you'd probably want to rearrange your grid so that it had the correct number of frames. There's a little bit of a balancing act usually, because when you first capture an effect like this, like if you render it out in Houdini, you can render out hundreds of frames, but it's kind of a challenge to get all those to fit into a grid. And so you kind of have to make some sacrifices and maybe just show like every other frame, and maybe make it fade out at the end so you don't have to show like the whole thing. There is a bit of an art to making these I call them like array textures, because it's like a whole lineup of frames. There is a bit of an art to making that kind of content. And you can spend hours or even days making a really good one of these things. So that's why I showed the asset store, because if you don't want to put in all that work, you can find somebody else who's done it and grab what they've done.
A great point. And again, a great resource. We're going to continue to try and put links for you all in the chat if we're using something that we feel will be useful. If you have a question and we can get you that resource, please let us know. Dr. Devil on the Twitch side says, I feel like this is one of those things that is both obvious and really hard to think of if you don't already know it. I love the frame lerping. So thank you for that as well. Saferix says, why is it twice as expensive? Isn't the compiler smart enough to know it's the sampling from the same texture, just from different coordinates and time?
Yeah, so the word expensive is a little bit overloaded. It's not twice as expensive in terms of the amount of texture memory that it's using, but we have to sample that texture twice. And sampling a texture in the shader is one of the most expensive things that a shader does. And so the fewer times you can sample a texture, the cheaper your shader is going to be. And in this case, we're sampling this one 2 times. And so this shader is going to be relatively more expensive because of the number of times we're sampling that texture. Again, so it's a little bit more costly in terms of GPU calculations. and it's not more expensive in terms of the amount of memory that we're using.
Very good very good explanation. I appreciate it. One more thing, Shadow Roy says, please do a live stream on UGUI shader graph. Is that
Okay.
your wheelhouse?
So yes, absolutely. In fact, one of the samples that we just barely released, and it wasn't in that list that I showed in this version of Unity because it's actually in a newer version.
Oh, cool.
We released a new sample set that is for people that want to use UGUI and shader graph together, because in Unity 6 we just released the ability or the support for to use shader graph to create UI elements.
Cool.
And so our newest sample is a large library of subgraphs that helped you to create UI elements with shader graph. And so in a future live stream, if you want me to come back, we could definitely go through some examples of building buttons and widgets and
That'd be cool.
sliders. And yeah.
Yeah. I feel like that's the type of thing that we see a lot in chat throughout. Anytime we're doing a live stream, people come in and be like, hey, do a live stream about this. Sometimes that's actually really helpful. And this is one of those situations where, Ben, you and I have kind of theorized, like, well, if we come back every month, could we do things like, hey, let's try to recreate what we've seen in a popular game and try and do that.
Yeah.
So if you guys have things on the topic of shader graph that you do want to see, keep letting us know, because we would love to be able to bring you that type of content. And also, like, four to five people just went, yes, please do that. So maybe we'll do that. Also, cool. I will shout out one more time. Go check out Ben's YouTube channel. As much as we enjoy this conversation and the back and forth and the casual nature of all of this, if you want like just directly to the point tutorials and overviews, go and check out Ben's content. It's exceptional. All right, Ben, anything else about Flipbook?
No, I think we should go on to the environment blending one.
I'm into it. Let's do it.
All right. So what I'm going to show you with this example is, so we've got a rock here. And for environment artists, making rocks is kind of like a way of life. It's what we do. And anything that we can do to minimize the amount of work that we have to do when making rocks is a good thing. So when we're making rocks, there's a couple of considerations. We want to make a set of rocks that we can use in all kinds of different environments. We want to use our rocks in a desert. We want to put them in the jungle. We want to put them in the forest. We want to put them in a snowstorm. And they need to feel like they fit in the environment. And the way that we're going to do that is by putting the material from that environment on top of the rock. So in a desert, you'd put sand on the rock. In a snowstorm, you put snow on the rock. In the jungle, you put moss on the rock, etc. And the other thing that we want to do is make as few rocks as possible while still making them feel unique. And the way that we do that is by making a rock that I can rotate in any random direction, and it still feels like it's good. Like if I make a rock that's flat on the bottom, for example, I can really only put that rock in one orientation in the scene. I can't rotate it upside down because it has this flat side to it, if that makes sense. Mm-hmm. So we want to make a rock asset that I can rotate any which way. And this is an example of that. So if I take our rock here and I rotate it around, if I stick it in the scene like this, it looks like a different model. And if I stick it in the scene like this, it looks like a different model. So I can rotate it lots of different ways and get lots of different reuse out of the same asset. Mm-hmm. But even though I'm randomly rotating this thing, I still want that environment material, snow or sand or moss, to stay on the top of it.
Right.
And if I were doing this sort of the naive way, I would build the rock, I would do my UVs, and then I would paint the textures, and I would apply the moss to wherever was on the top of the rock. But then if I rotated the rock, it wouldn't be on the top anymore. Does that make sense?
It does, because it literally just came up as well in chat, and it's a conversation that you and I had before setting up for the stream as well. Davina Duckworth says, if the rock had textures glued to them, wouldn't that be more efficient? And in some sense, probably, but ultimately having your moss or your snow now upside down because you readjusted how you were doing your rock, obviously that's where the value in this approach lies, I think.
Yeah, and efficiency is a very interesting term. It
Yeah.
would definitely be more interesting for that one rock. But if I had to paint a different texture for every time that I rotated that rock, now it needs a new texture with the moss on top when it's rotated this way. Now it needs a new texture when it's rotated this way. No, that's not more efficient because I'm using tons of textures. And if I painted it in, when I put it in the desert, I would need a new texture for that. And when I put it in, the snow, I would need a new texture for that. What we're doing here is we have a base rock texture, and then we're applying whatever the material is to the top separately. So that same rock asset with its same base textures can be put in any environment and we can reuse these assets. So efficiency, yes, on a small scale by just baking it in, but in terms of like your entire project, no.
I think there's also, and you touched on it a little bit, but the nuance between efficiency in terms of what Unity is doing in terms of draw and et cetera, and all the technical side, but also efficiency in terms of like human energy and hours put in. And
Yes.
there's two things to balance there as well. So I think I find myself getting kind of mixed up in the in the nuance of that as well.
Yeah. Okay. So I'll just look at a web browser here really quick. I have just a couple of, I just typed mossy rock into Google and did an image search. And you can see we've got a little bit of reference here. I could pick something like this and we've got moss on the top. The reason that I bring this up is whenever you're doing this kind of an effect, it's always important to go look at what it looks like in reality. And this is one of my favorite things to do, and to kind of decide like, what am I going to make this look like? What aspects of this am I going to try to imitate? And what effects am I going to leave out? Because reality is infinitely complicated.
Mhm.
And it's almost more important to decide what you're not going to do than what you are going to do.
We got a taste of this in the last one, and it fascinates me. I watch a lot of content about VFX and movies, and it's like VFX artists, and similarly, Ben, I imagine it must be the case for you as well,
Yeah.
just perceive the world so differently because you're trying to interpret every single ray of light and being like, how could I recreate this? And I think you're right as well. Realism is fantastic to a point, because there's a point in time where you're just like, this isn't really adding much. Or for me, in the example I use, and this is from a game design perspective, is the realism in Red Dead 2 is exceptional. It's beyond anything I think I've seen in most other games. But at the same time, I'm like, I don't need to sit here for 12 seconds every time I need to skin a rabbit, because that level of realism isn't as fun. So I sorry to interrupt, but I got excited. I'll shut up.
Yeah. No, there's a real art form to deciding what you're going to include and what you're not going to include. And you want to kind of decide what elements are the most impactful for this type of an effect, and what things are too subtle and you may not notice when you're just running by this rock on the way to kill your next enemy, that kind of thing. So it's important to look at reference and identify these are the things that are most impactful. And then these other things I could do if I have time or if there's enough performance budget. But if not, we'll just ignore those. So yeah, my point there is just kind of you want to always be looking at reference to get a good idea for what these kinds of effects should look like. All right, well, let's just jump in. And what we're going to do is create our rock effect so that, oh, here's something cool that I want to show you about shader graph. So normally shader graph has a main preview here that's a sphere. And you can also choose a custom mesh to use. So in this case, I'm going to choose rock. And for some reason, my main preview is not working. I'm going to close this down. And
give
we'll
it that power cycle. We were talking about that last week as well. Got to sound smart. Call it the power cycle.
Power cycle. All right, now it's working. So what I've done here is I've got a custom mesh in my main preview. Normally, like I said, normally this is a sphere.
Oh, cool.
or a capsule or something like that. But in my case, what I'm doing is I've chosen a custom mesh because I know I want to put this shader on a rock. I can just go grab a mesh from my project and say, well, there's my rock. I'm going to preview the material on my rock. So I don't actually have to look at it in my scene. I can just stay right in shader graph and see it in context on the object that I'm intending to apply it to. Okay, so what I've got here for my setup is I have two textures. I have a color texture and I have a normal map. And my color texture has the smoothness packed into the alpha channel. So I've got my color coming in to base color, and from my alpha channel of my texture, I have the smoothness of the rock. And then here's my normal. So that's what's giving me this this view of my rock. It's got a normal map applied to it and it's got color. And what I want to do is put the moss on it now. And so down here at the bottom, I have the moss color and the moss normal map. And if I plug these in, here's my moss color and my moss normal. And so this is what the rock looks like if it's just moss.
Cool.
And I think we can tell that this moss is not the right scale. We need to scale it down. And so what I'm going to do here is bring in my UV coordinates. And this is kind of like Battleship. You know, you got your numbers and your letters, and you're trying to find out where in this grid am I sampling the texture. And if I want the texture to be smaller or scaled, I can just add a multiply, and we can multiply our UV coordinates by, let's see, let's just try 10, see what that looks like. So I'll plug my UVs in here to my normal map and my color map, and we'll scale our moss down quite a bit. Just wait for it to compile. Yeah, so that looks a little bit more like the size of moss. And now the nice thing is I can zoom in really close and it still looks good.
Wow.
Okay, so now I've got a rock that's just covered 100% in moss. And that's not what we want either. We want a nice blend where we've got rocks some places and moss other places. So we just learned in that last tutorial that I can blend between two things using the lerp node. So I'm going to add a lerp. And we want to blend between the color of our rock and, oh, that's the alpha channel. Odd. Here we go.
I will say that the lerp node is my favorite one because
It's very useful.
fun. Well, that's going to be the favorite for a lot of people, but for me, it's just most fun to say.
Okay, yes.
I just like to say the lerp node. Let's get the lerping. Also, Toxicity Rose in Twitch chat says that's an interesting word, lerp. It's so much fun. You guys should try and say it out loud right now. No one around you will think you're weird.
It's short for linear interpolation. Interpolation is a fancy way of saying blend. And so we're doing a linear blend from one thing to the other thing. All right, so I'm going to plug in my color of the rock there, and then I'm going to plug in the color of the moss there. And then I'm just for now, I'm going to add a float node here, and I'll just give it a value of 0.5. And so now we're blending between the rock color and the moss color with 0.5, which means it's like half and half. And so now we've got a rock that's half rock and half moss. And that's, I mean, that's sort of doing the thing, but it's like moss isn't transparent, right? And that's basically what we've done. We've made the moss half transparent so you can see through it to the rock underneath. That's not quite what we want, but let's go ahead and do the same thing for our normal map. I'll just copy this lerp value. We'll plug our rock normal and our moss normal into there. And then we'll plug that into, there we go. Okay, so now we've got our normals. Wait a minute, I did something wrong. We've got our normals coming in here, and we've got our rock texture coming in here too. And yeah, that's really not working the way that we need it to work.
Mm-hmm.
Oh, I see. I plugged things in wrong. So let's see. Here we go. Better. Okay. So we've got our rock normal, we have our moss normal, and we're blending between that half and half.
Cool.
So what we really need to do is come up with a better way of doing this blend. So this is our 50-50 blend. And what we want to do is put the moss in areas where the surface is pointing up. And in order to do that, we just need to bring in a normal vector node. So this is a node that brings in the surface normals of the object, and the surface normals are just an indication of which direction the surface is facing. And so this normal vector has 3 different components. It has X, Y, and Z. But if I split out these components and we just look at the Y component, I'm just going to add a preview node so we can see what the Y looks like. You can see that this is white when the surface is facing up, and it's black when the surface is facing down. In fact, it's -1. It's like more black than black.
Whoa.
So this can be used as a mask to determine where we're going to put that moss. And so if I just plug this into the color so we can see what it looks like on our rock, what you're going to see is that it's white on up-facing surfaces and black on down-facing surfaces. And we can use that to blend between our rock color and our moss color. So if I just plug this in to our lerp, instead of the hard-coded values, so this is something interesting. Can you see, let me just plug this in. It'll be a little bit more apparent in our preview window here. Can you see this purple?
Yeah.
That is weird. And the reason that it's happening, all of the blending that we've done with our lerp nodes up until this point has been with an input, this t value, between 0 and 1. At 0, I'm going to get whatever color is coming into A.
Right.
And at 1, I'm going to get whatever color is coming into B.
Gotcha.
So I'm staying in the 0 to 1 range. But what happens if I give it a value that's negative? It's like lower than 0. I've stumped you. So
it doesn't take much, but yes.
So if we think of blending between our color on this nice gradient between 0 and 1, at 0 we've got our rock, and at 1 we've got our moss. If we go into the negative, I'm actually pushing beyond the rock value. If we put these on a line, I'm actually staying on that same line, but then going further.
Right.
And so what I need to do in order, and that's why I end up with this weird purple, because this is like the opposite color of that green.
Oh, okay.
Right? I hope that makes sense. So
no, it does. It does. And Angel and Engineer, I guess, says inverted colors. So it sounds like they got it. Okay. This is cool.
Yeah, that's right. And so if I want to prevent this from happening, this normal vector that I'm getting, the data is 0 up here. I mean 1 up here at the top where it's pointing upward.
Right.
But it's -1 down here at the bottom. If I want to prevent that purple craziness, I need to add a node that's called saturate. And what this node does is it clamps my values between 0 and 1 so that they don't go outside that range.
Gotcha.
And so now I can plug this mask in to my lerp, and the purpleness goes away, and I'm going to get something that's a little bit more natural.
Love it. Ben, I want to interrupt just briefly because I want to welcome on in some raiders on the Twitch channel here. So we got Layla Codes It bringing in their community after their stream. Thank you so very much for bringing everybody over. I hope that you had a fantastic time in Layla's stream. Right now, we are joined by the legend Ben Cloward, who is walking us through some shader graphs. We're doing 3 samples today. We are on the environment blend right now. The intention today is if you are not to recreate these exact things, that you are picking up principles and tangible use usable lessons along the way. So feel free. We're chatting. We're bringing in questions. If you have anything, we'll try to get to them. And thank you again so very much for being here. Everybody in the Unity community, if you want to go check out another excellent channel with some great vibes, please go check out Layla Codes It. And Ben, we'll throw it back to you.
Okay, cool. So what we've got now is a pretty good moss on the top kind of a thing. You see, if I rotate the rock this way, now I've got moss up here and not down here. But there's an improvement that I can make, and that is right now this mask that I've created is very soft. So there's this really nice smooth blend between, white up here and then black here. And I need to adjust this because in the reference that we looked at, when we saw the moss on the rocks, it was either moss or it was rock. It was not like transparently blended. And so what I need to do is adjust this mask that I've created to increase the contrast of the mask so there's a little bit harder edge. So that's what I'm going to do next. And it's pretty easy. All I need to do is multiply this. I'm going to multiply it by 8 and watch what happens here when I do this. I'm going to multiply this by 8 and you can see that now it just like crushed the range, right?
Yeah.
And then the next thing that I want to move this line up so that the moss stays more on the up parts of the face and not quite so much on the sides.
Gotcha.
And the way that I can do that is with a minus. So I'm just going to subtract here. Let me just close some of these so I have more space. I'm just going to subtract 2 from this. And when I do this, it's going to move my line up so that now I'm only showing moss on the kind of like the steeper parts of the surfaces.
Cool.
Okay, so I'm just going to clean this up a little bit. Yeah, now you can see I've got it's either moss or it's rock.
Cool.
And that's a little bit nicer. Now, one thing that I haven't done, right now I'm using this normal vector node. And so the normals that I'm using are the normals from the mesh. But I actually want to use the normals from the normal map because the normal map has a lot more detail in it. So here's my rocks normal map here. And I want to be able to take these normals and use them for the blending so that the moss is applied to all the little like bumps and nooks and crannies and stuff that only shows up in the normal map and doesn't actually show up in the mesh itself. And so what I can do, this normal map right now is in tangent space, which means it's relative to the UV coordinates on the surface of the rock. But I want the normals to be in world space so I know when they're pointing up. And so in order to transform my normals, I'm going to add a transform node here. So this is a node that does some matrix multiplication. And the nice thing is you don't have to know how that works at all. You just need to know that it needs to happen and tell the computer, hey, do this math for me. Because I don't really know matrix multiplication at all. I just know that, that this node can do it. And so we're going to pass this in, and we're going to transform that normal from tangent space to world space, and we're going to say the type is a normal. So now my normal map, instead of being in tangent space, is in world space, and I can grab it. And instead of using my normal vector, which is my mesh normals, now I'm going to use the normal map. And what we should see is that the blending here is a little bit more detailed. Can you see how I'm getting moss that's on top of these little indentations? So I get a much more detailed mask that's blending between my moss and my rock. And now I'm able to, rotate this around. And no matter how I rotate this, I'm always going to get the moss on top. Pretty cool.
I agree.
If I thanks, and if I were doing this, if I were doing this in production, I would want to expose these textures. Right now, these textures are just hard coded to the rocks and the moss, but especially for these moss texture slots, I can open up my blackboard, and this is a list of parameters that are tweakable in the material. And if I added these moss textures so that they were tweakable, I could change the material so that no matter what kind of environment I put this rock in, I could put sand on it, I could put snow on it, whatever kind of material. And now I can use the same rock asset, the same shader, and the same rock base textures, and just swap out the sand or the moss or the snow or the ash or whatever it was going to be to make that rock blend in with the environment.
This is great. I love this. And Angel Lanier follows up by says, once again, the virtual day is saved by the power of math. So I'm glad. This is excellent. This is so cool. And again, just the step-by-step. The one question I wanted to ask, if you could bring back the preview window slightly. I know we went from the normal and then we brought it in so that we changed up if it was mapping to the rock model or the mesh. I hope I'm using the right words here. Is that the process that you would recommend doing it in this order, or could you cut out that step by using what we switched to at the end from the beginning? Does that make sense?
Oh, I see. So if your normal map, you could create a normal map that is in world space already.
Yeah. Could we kind of like reorder it?
You could, yes.
Okay.
That's not a very common thing to do.
Gotcha.
I would say like 90% of normal maps are in tangent space. And so if you wanted to save a little bit of performance, you could absolutely bake your normal map in world space. However, you would not then be able to rotate it.
Got it.
Once you've baked it in normal space or in world space, it's going to be in world space. So you're going to have to do a little bit of math, like regardless of how you're doing this.
Sure.
So I think that this is probably the best way, just in terms of a balance of, performance and that sort of thing. Yeah.
Gotcha. Yeah. Just in terms of like the process, I kind of was like, oh, well, we did everything this way the entire time. And then at the end, we switched the beginning. So I was like, oh, okay. But no, that was perfect. I really appreciate it. Have we put a button on this? Can I bring in some questions, or is there anything else
absolutely.
we want to talk about?
No,
great.
That's what I wanted to show.
This was awesome. Thank you again already. And I've said it repeatedly, but this is the type of thing that the way that we go through this and what you show, Ben, it makes me think that I could do it. I could get in there and I could get to work on this, which is awesome.
Yeah.
We've got Altamarn on the Twitch chat says, can you use shader graph to scatter smaller rocks meshes into cavities, or are we limited to textures? Is there a way that you can see very quickly to solve this? My brain is already trying to piece it together, even though I have very little in terms of experience and knowledge.
So there are two main things that shader graph can do. It can manipulate vertex data, which are UV coordinates, positions, normals, that sort of thing. And it can also manipulate pixels. And pixels would be like a color. So what we've calculated here are the color values of all of the pixels. So if we come over here and look at, this is called a master stack. We have this vertex data, so I can alter the position of the vertices. I can alter the normal of the vertices. And I can also alter the tangents, which are basically perpendicular to the normals. And then on the fragment shader, I can change base color, normal, metallic, smoothness. So these are the properties of the surface. And ultimately what we're trying to do is figure out what color every pixel is on here. What you're referring to, I think, is duplicating meshes. And that's not something that shader graph can do. You would need to use another tool in Unity to do that sort of thing, like the terrain system has a scatter tool that would allow you to like scatter rocks around. Generally, when you're thinking of like positioning meshes, that's something that the engine does, but shading pixels is what we're doing with shader graph.
That's a great distinction. Thank you for clarifying that. False Bracket also points out on the Twitch chat that you can't do that in shader graph, but you likely could in VFX graph. So if you're looking for another opportunity or another tool, another outlet. Bagardi Tech on the Twitch side says, how well would shaders work with LODs, as the shader is based on normals and LODs have weirder normals due to fewer polygons?
Yes. So If you switch LODs, you would have a different configuration of normals. And so the effect that you're seeing here would probably change. However, the redeeming factor there is when you switch, you've moved the camera back, so you're further away. And so that change is less obvious. So you will see a difference because the normals are different, but that difference will be subtle because you're moving away and seeing the object smaller on the screen.
Very nice. Very nice. Again, I'm keeping track of all of the Twitch and YouTube comments as they come through. If you have questions, feel free to ask. We're going to do our best to get them in front of Ben. Obviously, we won't have time to get to every single one, so please go and check out Ben's YouTube channel as well at Ben Cloward. Lots of very detailed, very straightforward tutorial and overview type content. Cannot recommend it highly enough to you all. We also have questions about, are there additional spaces in which we can go and ask questions and follow up? I'm directing everyone to discussions. I don't think that there is a dedicated, as pointed out, I don't think there's a dedicated space just for shader graph conversation, but the people in those spaces are usually very, very helpful. And I think I work with a lot of the team that is working on discussions, and they are adamant about getting more answers to you faster. So while there might not be a dedicated space, throwing out your question in there will likely get you the level of, hopefully, the answers that you need in some engagement.
There is absolutely a dedicated forum for shader graph. So,
is there?
Yeah, if you just Google shader graph forum, you'll find it.
Perfect. That's what I like to hear.
I do want to
also go ahead, Ben.
I did want to jump in. I have an example for that last question about what it looks like when you move further away. This is a scene that I showed in our last stream that I just happened to have. And what I've got here is a bunch of rocks with that effect. So if we're looking at this rock here, as I back away, it's switching LODs.
Oh, okay.
I don't know if you can see that. It's like this one here. It popped right there, pop. And then
I don't think I'm getting that level of detail. Oh, maybe
and
I am.
That's kind of the point that I'm making. Like as you zoom out, it does pop, but it's small enough that it's not something that you're gonna like. You really have to look and pay attention to it to see that. So anyway, that's like a
Cool.
visual example of what I was talking about.
Perfect. I mean, where we can, that's the way that we like to do it, right? A show don't tell. We're not necessarily just going to explain it to you, but being able to showcase it is excellent as well. I know we have more questions coming in, but we have a whole other sample/example that we want to dive into. So if we have time at the end of the stream, I'm still pulling these questions. I'll still hold on to them and ask as many as I possibly can. But for now, Ben, what is our third and final sample of the day?
Right. So for this sample, I'm going to show you a really simple way of imitating the behavior of cloth shading. And my intention here is not to do a physically based simulation of how light and cloth interact, but I'm trying to show a really simple way of making your surface look more like cloth. If I were going to do this, well, I'll get into that in a minute, but first, let's start out by looking at a couple of reference images. So here's the moss that I had a little bit ago. So cloth does something really interesting in that because it has tiny threads, it redirects the way that the light is reflected.
Mm-hmm.
So we're looking at an image of silk here, and you could see that there are these highlights that are kind of along the ridges, and it's a little bit darker at the angles. So when I'm looking right at it, it's like kind of brighter on that ridge, but then as it falls off, it's darker. That's an interesting, unique characteristic of silk and cloth like satin. Here's another example. You can see these ridges are bright, but then as it falls off, it gets darker. So there's kind of like this this redirection of the reflection of the light that's happening. If we look at other kinds of cloth, so here's a knit pattern. And if you look really closely, you can see that there are like tiny little threads or hairs, fibers that are sticking out from the surface.
Mm-hmm.
And those tend to catch light on the edges of the cloth. And it's kind of the opposite of what we saw when we were looking at the silk or the satin. So in this case, the edge of the cloth is brighter and the interior is not as bright. And here's another example. I don't know if you can see this. These are kind of small details here, but you have these little threads that are sticking out all along the edges, and they catch light and they make the edge surfaces brighter than the interior. So these are the two effects that we're going to try to simulate today. And like I said, I'm not showing a physically accurate representation of what light is doing. In a HDRP render pipeline, there is a mode that you can set the shader to actually physically model these behaviors. But that's not what I'm showing. I'm going to try to show something that's a little bit more simple and basic, but also pretty easy to set up and pretty easy to control. Okay, so with that being said, what I've got here is two textures. I'm using denim as my example, but you can use whatever textures you want that look like cloth. So with this, I just took my phone and took a very close picture of my blue jeans.
Oh, wow. Okay.
Yeah, pretty easy, not too hard. And so I've got the color texture and I've got the normal map. And what we want to do is change the shading on this so that it feels a little bit more like denim. And what we were saying when we were looking at the references, the satin and the silk are kind of brighter in the middle, and then the cotton is kind of brighter around the edges where you see those little microfibers. And so the way that we're going to simulate this is with an effect that's called Fresnel. That's Fresnel. There's actually a node in ShaderGraph that does it. And it looks like it should be pronounced Fresnel.
Okay.
But that's not wrong. This is named after a French guy. And so we're leaving out letters and it's just Fresnel, right? Okay.
Yeah. Shout out to any of our French audience. Thank you for skipping letters wherever you feel like it.
It's kind of a cringe thing to me when I hear somebody say Fresnel. Although that is kind of cool because it means what they learned by reading instead of by hearing. And so that's okay. But just so you know, it's Fresnel.
Got it.
And what a Fresnel effect is it's a way of shading something different based on if you're looking straight at it or if you're seeing it from a glancing angle. And so instead of using that node that I just showed you, the way that I'm going to calculate it is with our view direction node. This gives me a vector that's coming from the surface and pointing at the camera. And then I'm going to use the normal vector node. This is the same one that we just used for the moss example. And so what I'm going to do is compare these two vectors. I want to know, is my normal pointed at the camera or not? And the way that I can tell that is by doing a dot product between my view direction and my normal. And so here's my dot product node. And if I wire these two together, now what you can see is it's going to be white wherever that surface is pointing toward the camera. And where it's perpendicular to the camera, it's going to fall off to black. So it's kind of hard to tell here, but this actually is wrapping around. And if we could see the full edge, you would see that it went all the way to black. So this is my Fresnel effect. And I can use this mask now to create some cloth-like effects. And so what I'm going to do next is this one is giving me that like straight on kind of silk or satin view, but I need to also modify it with a 1- to get the opposite effect where it's brighter on the edges and darker in the middle. So now I have two masks and I just need to alter these or kind of fine tune them to get the results that I want. And the way that I'm going to do that is just by adding a power node with a value between 0 and 1. You can use the power node. It's raising it to a power, but you can use the power node as a contrast adjuster. And so if I set the power to 1, Now it looks exactly the same as the original value. But as I increase this power, you're going to see that this brighter edge is going to get shoved further and further toward the edge. So the higher that power is, the more I'm just seeing the effect on the very edge. So for now, I'm just going to leave this at 4. And then the other thing that we're going to do is multiply. And this multiply is just like a brightness control. Basically, I can say like, oh, I want it to be twice as bright or half as bright, that sort of thing. Okay. So I've got a power value and a multiply value. This is controlling the contrast, and this is controlling the brightness of the effect. So now I can take these two nodes, and these are the ones that are controlling the brightness on the edge, but I'm also going to add them to the same effect that we had down here. And this one controls the effect in the middle. So we've raised our power to 4 for the middle there, and then we have our multiply that's controlling the brightness there. So these control the edge, these control the middle, and I can just take them and add them together. So, whoops. I'm going to grab all these and move them over just a little bit to give myself some more space. And then I'm just going to add the result together. And that gives me this, which, so you can see there, I've got the edge and then the middle. And let me just make sure that I've done everything. Oh, I've got this set to multiply by 0.2. I actually want that to be 2. There we go. Okay, and so now what I can do is I can just take my denim color and multiply it by these values here. And that's going to add in those effects. And then I can pass it out. And what I'm going to end up with is something that looks a little bit more cloth-y.
Yeah.
Right? And I can take these 4 parameters, the contrast and the brightness of the edge effect, and the contrast and the brightness of the middle effect, and tune them so that it feels more like what I'm seeing in the reference. So in this case of denim, I don't have a lot of like brightness in the middle here. So I'm going to tone this one down. So maybe it's like 0.5. And now I'm going to get something that's a little bit more like denim. But if I wanted this to be silk or satin, I could really crank up the brightness of the edge effect, and then, turn down the brightness of the edge effect, but turn up the brightness of the middle effect. And then obviously I could bring in other textures, and I could get something that is starting to look a little bit more satiny.
Sure. Is there like a rule of thumb, or is it just purely experimentation and kind of changing those values and poking around with it?
Yeah,
like,
I mean, this is looking at your reference image
Sure.
and trying to match what you see. Like I said, this is an approximation. It's not really like a physical imitation. I'm just looking at, like, I think this looks more like satin. I think this looks more like cotton.
Right.
And you can dial in your own values here for how much edge you want and how much like middle brightness you want.
Yeah. It was something we put in the notes as we were prepping that you were like, we have to tell them this is not physically accurate. And I was like, okay, good. All right, good. We're there.
Yeah.
That's important to take away.
This is a pretty popular technique to use. I use this on the characters in Anthem.
Oh,
and
cool.
So yeah, so the cloth on the outfits of the NPCs that you saw around the world, we're using this kind of an effect for various kinds of cloth.
Awesome.
Yeah. Okay. I think that is it.
Crushed it.
Well, thank you. I do have some other textures here. Let's see. So I have a little library, and all of these, like I said, for the denim, I took a picture of my jeans. I think I scanned a shirt to get
Oh,
this
no way.
silk texture. You just take whatever you have and take like a really close-up picture of it, and that's what you can use for the various textures here. I have cotton, color and normal. I have denim, normal, and then here's silk example. So I could throw these textures in here and get lots of different cloth effects. Basically, just by adjusting those 4 parameters and then either brightening or darkening and changing the contrast of the edge or the middle lighting.
Yeah. An important comment coming through in the YouTube chat here. Again, an Angelinier crushing it. Also, really difficult name to say, but crushing it. The sphere gives a kind of wrong impression of how effective this really is because cloth is never really has a shape, right? So you see it on the
True.
sphere and it's so
Yes.
like clean, and then as soon as it was on any form of actual material, it would be so much more
Yeah.
haphazard and random in its shapes, right?
Yeah. So had I been prepared, I would have made a. Oh, look at that! There's a curtain
We got
mesh.
a curtain.
Let's try it.
Okay. We'll do it on the fly. We're doing it live.
This is totally off script, but yes,
Whoa,
absolutely.
okay.
Can you see how that looks like very
Yeah,
satiny as I move it around?
it does. And
Very
even
good
like
point.
without my brain doing the deep analysis, it's effective enough that my brain concludes that is it's familiar in that sense.
Yeah. So
Okay.
if I were taking this, I would actually, I can actually do this. We can make this like 12 so that our texture is much more tiled, and then I can tune these values, like I said, to get something that's like the type of cloth that we're trying to get.
Yeah. Oh, this is great. I'm glad that we did this. That's excellent. Okay. Ben, anything else on this, or are we ready to pull in some questions?
Yeah, we're done with this example. Go ahead.
This is exceptional. Again, thank you so very much. Everything that you've presented is so like clear and well explained. And like I said, as someone with no experience, I feel like I could run in and do this as well. So we have a couple of questions that we pulled earlier from Mr. Awesome on YouTube. Says, do you find that consistent style is important for immersion? Now, I believe this was when we were working in the environment stuff with the rocks, but just in terms of, I suppose, styling your game design in general, or styling your art in general. What do you
Yeah,
think?
the visual style of your game is something that you want to come up with as early as possible in the process. I think that there's this impression that like, oh, we can make the whole game and then just change the shaders at the very end and come up with the style. But definitely don't do that. You want to establish a consistent style at the beginning, and then everything that you do is going to support that style. The way that you create your textures is going to support it. The way that you do your post-processing effects is going to support it. Even the shapes of your models are going to support the visual style that you've come up with. So
Hmm.
that's something that you want to establish very early on and then keep it consistent. I know that when projects go on for a long time, that style can kind of evolve over time, and that's okay, but you want to try to establish that very early on so that all of the content that you're creating, textures, meshes, shaders, post-processing, all of that stuff can lean into and support the visual style that you're trying to create.
Love it. I have a question here from Eamon on the Twitch side, who, for context, earlier mentioned that they have a geology degree. They said, I'm curious about the rocks. Is there any thought put into which rocks go into which area, specific formations, or keeping it uniform geology in the area? So, obviously, not from today's tutorials, but in your experiences, Ben, in your years of experience in the industry, do you have any insight into this?
Usually the appearance is mostly going to come down to the style and also the type of reference that the artists looked for. Um, so, if you're a geologist with experience of, various layers of geology and that sort of thing, that's something that you could bring to the table and make an area feel, that more realistic because you've identified geological features that are local to a specific area and included those. That can add a ton of realism to something, but probably not something that most people are going to notice, honestly. And so they're
Yeah,
going to be looking for um, uh, consistency of style rather than consistency of, oh, you wouldn't get that geological strata at that latitude, or that sort of thing. Most people
sure.
aren't going to be aware of that, but they are going to notice, like, oh, if you have like a red rock area and there's a rock that's like granite.
Sure.
It's going to stick out. But I think that's maybe a little bit too like trying to get like realism in geology is maybe a little bit more than most people are going to be looking for.
Yeah, I think inevitably, I think in any element of game design and game creation, you're going to find someone who notices the very specific like considerations to real world and that realism, and kind of what we talked about earlier, where it's like there is almost a level of diminishing returns of like you went full realism, but did it add for the masses or was it for like the couple of individual people, which I think is rad.
Yeah, I have another example on that.
Please.
Actually, my son is a bird watcher, and he can
Oh, cool.
identify birds by their calls. And he's all the time coming in when I'm playing a game and being like, "Oh, that's a kingfisher call, and those birds, this game is set in Australia, and those birds don't exist there."
I
I'm just
love
like,
that.
really?
I genuinely love that. Like that's the one person, you know what I mean? Where if they went the extra mile to be like, no, the calls, there are a smaller population of people, but people will notice. I love that a lot. There is an example. I watched a video essay by a creator called Any Austin on YouTube who reached out to, was it Bethesda that did Starfield?
Starfield.
It is Starfield. Yeah. Okay. Reached out to the developer to say, hey, I'm on this planet. I'm trying to figure out what all of these pipes actually do and like the passive environmental storytelling. And he actually reached out to them and he was like, these are my guesses. Is this pipe this? And he did like engineering research and they came back and they were like, actually, yeah, we use some inspiration from real world, like transportation of dangerous chemicals and things. So yeah, that's what this pipe's meant to do. So again, it's like if you get super granular into those details, someone will notice. But it's are you willing to put in that level of energy for the handful of people? Yeah. I do want to bring in, there was one other question I saw, and then Ben, I have a curiosity, and I know we only have a couple of minutes left, but we'll see. It might not even be something that we can do. But Bailey Gray says, I'm new to parallax materials, but have experimented with it in other software. Can the shader graph in Unity help with navigating something like that, such as a 3D material behind a window?
Yes. And in fact, if you download the feature examples sample, actually, don't share my screen yet because I'm kind of doing some behind the scenes here, but I'm going to pull up a scene that shows an example of that. If I have the content set up, let me just take a look really quick here. I do. Yeah. So I'm going to open this scene. So if you go into the package manager and go to the shader graph package, go to the samples tab there and download the set of samples that is called the feature example sample. And you can share my screen now. I'm just going to fly over here to this example here. This is called interior cube mapping. And if we take a look at this cube, you can see that I've got exactly what you're looking for there, where this is just a cube. There's no interior geometry. There's no mesh here, but the shader is imitating the look of an interior. And this is done a lot in games, like the Spider-Man, I think, is the most popular one right now.
It just came up in chat as well.
But you can crawl along the walls of the buildings and look in, and you get this kind of an effect. But there's no interior there at all. Now, if you want to see how to do this, this example is available right now in Unity in the package manager. Here, I'll just show you. Package manager, shader graph, samples, feature examples. There's an example right here on how to do interior cube mapping.
Yeah.
And there's also this other effect.
Go.
If you don't mind me showing more, this is called parallax occlusion mapping, and it's a similar kind of an idea, but it's adding more detail to a surface than is actually there. So this makes it look like all of those stones are bumping out of the surface because of the really neat parallax that you see. But none of that is actually real. This is just a flat cube.
The cube is gaslighting you.
It is absolutely.
It's
That's
gaslighting you.
the whole point. When
Yeah.
you make a game, like your entire game is gaslighting the player into thinking there's a world that exists that does not, right?
That's a
And
good
so,
point. That's what immersion is in a way, right?
yes, yes. So
Um,
this
I
sample is available, and there are tons of other examples like that here. If you want to learn how to do these kinds of things, go download it.
Yeah. I think two things. One, I'm slightly proud of myself because as I asked that question, my mind immediately went to this sample that we went through in the last stream. So I feel like I'm learning. I don't feel like it's just hitting me and bouncing off. I think I'm absorbing some of it. But I'm seeing a lot of people that are really impressed with this thing that you just showed. We went into relative detail with it in a stream we did a few weeks ago. I've put that link in the chat as well if you would like to get in there. And then, of course, if you want even more detailed tutorial and overview type content, please go and check out Ben's YouTube channel. Now, Ben, for extra credit, and this we can completely ignore it, it's extra credit, but Jonathan Vastalikin in the YouTube chat asked, could we get a denim rock? Could we combine things we worked on today and take the cloth shader and make our rock denim? Is that something you feel that we could do in in the 5 minutes we have left? Just to appease our audience, you know what I mean? What do you think?
So unfortunately, when I switched, I didn't save what we had done. So yes, we could absolutely do that. Oh, I have. Yes, 1 second.
Okay. And Ben, don't feel like you have to do this. Let me make that very, very clear. This was just a fun and silly request that I thought we could have a good time with.
Well, we can absolutely do it because it's easy.
Love that.
So yeah, go ahead and share my screen here.
In.
So yeah, all we have to do is, so this is the shader that we set up, and I just have to do a custom mesh here and find my rock.
Boom. There we go.
I've got a denim rock.
We got a denim rock with like a satin finish, it looks like too.
Yes.
Our lighting still set up. I think it's great. We combined all of the things. Oh, that's great.
Okay.
Well, thank you for doing that, and thank you for the suggestion, Jonathan. I hope that you're still here. I hope that we didn't ask this question, or you didn't ask the question, and you're like, I got to go do something else, and we did this for the rest of our friends here. But I absolutely love that. I think in terms of the questions we got through, a lot of them, as always, if you want to learn more, please go and check out Ben's channel. We'll link to it again right now. Ben Cloward on YouTube. And then beyond that, if you wanted to connect with more people in the community, you could use our discussions or Discord pages, a number of community spaces, lots of Unity folks in there helping answer questions or direct you to additional resources. Ben, this was awesome. Thank you so very much for joining us again. Engaging in a way that with little to no experience, I am motivated. I feel that I can do this. So I hope that everybody watching here today feels very similarly. Go tinker around, go learn, go experiment in Shader Graph. It is a very powerful tool. Ben, do you feel like coming back another time? You got some more things that more nuggets of wisdom you could share with the gang?
Absolutely.
That's what I like to hear.
Super fun. I love doing this. It brings me a lot of joy to do this kind of work, and I just love sharing it with you guys.
Awesome. And I'm grateful. I hope you in the community are as well. These are, again, very fun ways to kind of just unpackage this and experiment and chat about it as we go. Very conversational and casual in a way that I hope is very, very approachable, because that's kind of the vibe that we're shooting for here. Ben, thank you again one more time. Don't go anywhere. I'm going to sign off with the gang, but we will catch up as soon as we wrap up the stream.
You got
Thanks so much, Ben. And Unity community, with that, it is just you and me. We're going to wrap up today's stream. Again, please go and check out the Discord and discussions pages. If you enjoyed this video and you want to see more content like this, please throw a comment in the YouTube channel after the fact. Or honestly, I'm paying attention. I'm monitoring the chat as we go along. So keep giving us this feedback. If this hits for you, if it's useful, if it resonates, if you just like to be here to hang out with the community, please let us know. Again, we are live on these channels, usually 2 times a week, often almost every Thursday. There is one coming up in June that is a holiday that we'll need to take off, but we're aiming for every Thursday. Also, next week is the Switch 2 launch on Thursday, so we are not streaming that day as we want everyone to go and enjoy Switch 2 Day. But we will be live next Tuesday. But before we get to next week, tomorrow is our next stream. If you are looking for a very fun way to hang out with the Unity community, come on back for Versus Mode. This is our Unity-made game show about games. It is silly. It is fun. You all can play along, and you have control over the game. We give you polls and ways to influence each rounds, modifiers, etc. So please come and hang out. We've got our very own Michael Saver going up against Jeff of Ritual Studios. It is silly. Again, to give you a little bit of context, one of the recurring rounds is Drawn to the Game, where we ask our contestants to draw a popular video game character from memory in 30 to 60 seconds, and then you vote on which one is best. So come and hang out for that tomorrow. I will put that link in the chat right now if it works. It did. So you can go and hit that notification bell and come on back tomorrow at 12 p.m. Eastern, 9 a.m. Pacific, or 5 p.m. GMT. I said or. It's the same time. But either way, thank you so very much for being here, Unity community. You guys, Denim Rock. Crush that. We will see you again next time. And thank you again to everybody for making this happen. Thank you for being here. Thank you to Ben, and thank you to Jack working behind the scenes. Until I see you all again, everybody, my name is Jackson. Have a great rest of your day.